Okay, so in this video, we're going to learn how to factor trinomials. When we say the word trinomial, we're looking for something that has three terms, hence the prefix tri. And generally, these are going to be in the formula of ax squared plus b plus c, where the a, the b, and the c are coefficients. They don't have to be whole number coefficients. They are coefficients, and so we're looking for something that has 1, 2, 3 terms, and then 2 x variables. Now, this x squared over here, and I'm going to highlight it in yellow so that it is emphasized, and this x means that we're going to have to approach this type of factoring differently, because you can't pull out an x, it's not in the third term or the c. And these two are not like terms at all, so they can't be added or subtracted. So we're going to have to go about this another way. In this video, we're going to show you how to go about factoring a trinomial in which the degrees of x differ. Now, in order to show you how to approach these, let's solve it in the context of an actual question. So here we have 3x squared minus 2x minus 5. And one thing to keep in mind is that these are always set to be equal to 0. So I'm going to write that along with the general form. Okay, so the first step is going to be to multiply a and c together. And so when I label this, remember that the coefficients are listed in this order. So the a is always attached to the x squared, the b is always attached to the x, and then the c is the value without an x. So a and c, that would mean that it's 3 multiplied by negative 5, and that equals negative 15. Step 2 would be to list all the factors of a times c, which in this case would be negative 15. So what I'm going to do here is I'm going to write negative 15, and I'm going to carry on the x squared as well, but it's not necessary. So I'm going to go negative 1 and 15. We have negative 3 and 5. And then we have 3 and negative 5. And I'm going to highlight each of these factors over here. The third step is to select factors that add up to the b value. And remember that the b value is the negative 2 here. So when I look at negative 1 and 15, negative 3 and 5, and 3 and negative 5, I could see that these factors here add up to the b value. And so what I'm going to do is I'm going to put an x beside each of these. And the reason why we're going to do that is because when I multiply these, they're going to give me the x squared. So I've chosen 3x and minus 5x. So we're going to insert the factors into the original trinomial by replacing b. So instead of writing minus 2x, we're going to write 3x squared plus 3x minus 5, which is equivalent to b minus 2x, and then minus 5 over here with the c. Lastly, then we're going to factor our equation by something called grouping. And what that means is I'm going to take this polynomial and divide it into 2 groups. And then I'm going to factor each group separately. So if I look in the first group, 3x squared plus 3x, I see that I can factor out 3x. And when I factor out 3x from each of these, I end up with x plus 1. Because 3x squared divided by 3x gives you x, and 3x divided by 3x gives you plus 1. Now, if I look at the other group over here, I see that I have minus 5 that I can pull out of each of them. So I'm going to remove minus 5. Now they both don't have x. So, or I should say only one of them has x. So we're not going to factor out x. It's not a complete common factor. So I'll pull out the 5. And when I go negative 5x divided by negative 5, that gives me just x. And then negative 5 divided by 5, negative 5 is going to give me plus 1. Lastly, I see that I can actually factor out x plus 1 from this entire equation here because that is common to both. So I'm going to factor one more time. I'm going to factor x plus 1 out of here. And when I do that, what remains? Well, the 3x minus 5 remains. And these are the two factors, or I should say, the factors, or the factor form of the original trinomial that we gave you. Now, another way to think about this is, and I'll highlight these in orange, is whichever shows up twice, whichever factor shows up twice, you can just pull that factor out immediately. So I'm going to write it over here. Whichever factor shows up twice, you can always factor it out. And we'll say that for the last step. All right, for our second example here, we have 2x squared plus 5x plus 2. The first thing that I'm going to do, kind of a pre-step, is I'm going to label each of these coefficients here so that I know what I'm working with. So the 2 is A, the 5 is B, and the 2 is C. And so the first thing is going to be to multiply the A and the C together. So that'll be 2 times 2, and that's going to give me 4. And it's actually giving me 4x because it would technically be 2x squared multiplied by 2, and that's 4x squared. The next thing we're going to do is list all the factors of the product A times C, or in this case it's 4x squared. So we have 1x times 4x. We have negative 1x times negative 4x. And then we have 2x and 2x. All right, now the third part of this is going to be to choose which of the factors add up to our b value of 5. Well, we can see that 1x plus 4x equal 5. So I'm going to write that down as 1x and 4x. And another thing before I get started on solving this here is that, remember, we should be setting this to 0 because these are always set to 0. So what I've done is, for the fourth step, is I have rewritten the b value of 5x as the two factors from step 3. So that would be x plus 4x. Lastly, I'm going to group this trinomial into two groups and then factor each group separately. So the first group will be 2x squared plus x, and I can see that there's an x that is common to both of these inside that group, but then nothing else. We'll pull out an x. And by pull out, of course, we mean divide. When we take 2x squared divided by x, then that will just give us 2x. And then x divided by x is 1. And then for the other group over here, I could pull out a 2, since that is common to both. And so when I divide each by 2, then that would give me 2x plus 1. Like we said previously, whichever one occurs twice, you can always just simply pull that out or factor that out for the next step. But mathematically, what's actually happening here is that now this expression has 2x plus 1 common to each term. So we can actually just factor it out because of that. Or you could think about it as, well, since it shows up twice, I'm going to factor it out. So regardless, we're going to factor the 2x plus 1 out. And when we do that, all we're left with is x plus 2. And so these are the factors of this trinomial over here.